student, I am Dr. Anamika Goyal from ABES Engineering College, Ghaziabad. Today I am going to discuss about the another string matching algorithm, that is Rabin Karp string matching. In my previous lecture, we already discussed naive string matching algorithm. In naive string matching algorithm, basically we find all valid shape for possible match, and basically in naive string matching algorithm, for a we just find the pattern into a given text array, one by one for all the valid shift. So here the total time complexity of naive string matching algorithm is order of n minus m plus 1 dot m, where n represent the size of text array and m represent the size of pattern. So here in today lecture, we'll discuss first Rabin-Karp string matching algorithm. So in Rabin-Karp string matching algorithm, first we calculate a hash value for the pattern as well as for each m character subsequences of text to be compared. If the hash value are unequal, the algorithm will determine the hash value for next m character sequence. Basically, if the hash value are equal, the algorithm will analyze the pattern and the m character sequences. In this way, there is only one comparison per text subsequences, and the character matching is only required when the hash value match. So basically, in Rabin-Karp string matching algorithm, first we try to find out in string matching algorithm, basically to find out the pattern into a given text array, first we compute the value of hash function, right? And then we try to find the match of this particular hash value into a given text array. If our hash value is matched, then only we compare or we analyze the pattern, otherwise not. So in that case, basically the difference between naive string matching and Rabin-Karp is here. In Rabin-Karp, to find a pattern into a given text array, we just calculate the value of hash function. And in naive approach, what we have to do, we just compare the pattern for all valid shift values, right? According to Rabin-Karp string matching algorithm, we have two cases. Case one, in naive string matching algorithm, we just compute the hash value. To find out the hash value, first we find a random prime number, that is nothing but q. And for calculate the hash value, we use a formula p mod q, right? P mod q. So in if the value of if we find the p mod q value into a given text array, then only we analyze the pattern. So in Rabin-Karp string matching algorithm, we have two cases. Case one, if our p mod q value is equals to t mod q value, then there is an exact match. If our given hash value find into a given text, then only we analyze the pattern. If P mod Q is not equals to T mod Q, then there is a spurious hit. So basically in Rabin-Karp algorithm, we find two kind of match. First one is the valid match and second one is the spurious hit. Valid hit means our hash value match, and after matching the hash value, we compare the we analyze the pattern and pattern is found. So this is a valid hit. If in the second case spurious hit, our hash value is matched, but when we analyze the pattern, then pattern is not matched. So this kind of hit is called spurious hit. So to understand the concept of Rabin-Karp algorithm, let us take an example. So according to that example, we are just giving a value of q is equals to 11. Here, what is q? Q is a prime integer, that is 11. जनरली ये क्यू की वैल्यू में गिवन होती है, अदरवाइज वी सेलेक्ट एनी रैंडम वैल्यू विच इज अ प्राइम नंबर. एंड वी इन दिस क्वेश्चन हाउ मेनी spurious hit does the Rabin Karp measure encounter? So we have to find the spurious hit in this given string text array, and when looking for the pattern is P26. So in this case, the pattern value is 26 and the value of Q random integer is 11. So first we have to compute the hash value using Rabin Karp. And the formula for compute hash value is what? That is P mod Q. I already told you that is the formula for compute hash value, that is P mod Q. Here you can see the value of P is 26 mod Q. 26 mod Q means 26 mod 11. If you divide the 26 by 11, so the remainder is 4. So this is what here you can see your hash value is 4. So I think so I hope you understand how we can compute the hash value. So as per the Rabin-Karp string matching algorithm, first we compute the hash value. Now one by one in a given text array, we match our hash value, right? This is the Rabin-Karp string matching algorithm. We just first we discuss the approach. After that, we see this algorithm, right? So to understand the approach, we continue our previous example. According to that example, the given text array T is. First, we note down the given text array T is. The text array T is 314159. 314159, then 2653, 2653, 589793, 589793. This is what? This is the given text array. And the pattern is 26. So our pattern size is 2 bit. So what we have to do, one by one we select 2 integer into a text array and find out the mod of 11. So our first two integer is 3 or 1. So we compute here mod 11. 11 is the value of Q. If we compute 31 mod 11, so the remainder is 9. So the remainder is 9. I hope you understand. So again we take another two integer, that is 1, 4. And if we compute 14 mod 11, so the remainder is 9. Again match not found. Then next two integer 41 mod 11. 41 mod 11 is 8. Again match not found. Then next is 15 mod 11. Here we found match 1. This is what? This is, yeah, this one is match. Then again we take next two integer 59 mod 11. 59 mod 11 again 4. Then again we compute 92 mod 11. Again we found 4. Again we compute 26 mod 11. Again 4. So here we found 4 times our hash value match into a given text array. Then again we take two next integers 65 mod 11, that is 10. 65 mod 11 is 10. Then again we compute 53 mod 11 is 9. Then again 35 mod 11 is 2. Then again 58 mod 11 remainder is 3. Then again 89 mod 11 remainder is 1. Then again we take two integer 97 mod 11 is again 9. Then again we take 79 mod 11 is 2. Then again we take 93 mod 11, that is remainder is 5. So here you can see in the given text array we find a match 4 times. We found 4 time match our hash value, right? The next step after finding the hash value match, what we have to do? We just analyze the pattern. So our first match is 15 mod 11. That is what? That is 4. Here you can compare our pattern. Our pattern is, but our pattern is 26, right? Our pattern is 26. 26 not match 15. So what happened? This is called spurious hit. Spurious hit. So I hope you understand what is spurious hit. Spurious hit is when hash value match but the pattern is not match. So this is spurious hit. Our next match is 59 mod 11. Remainder is 4. Again, pattern is not matched. So, this is spurious hit. Our next pattern is 26 mod 11. Again, value is 4. Here you can see pattern 26 match 26. So, this is what? This is valid hit. This is valid hit. Next value is 65. 26. Next one is missing 92 mod 11 again found 4. So this is again spurious hit because pattern not found. So in that example you can see here we have one valid hit and three spurious hit. I hope you understand the approach of Rabin Karp string matching algorithm clearly. So I hope working of Rabin Karp is clear. Now we see the step-by-step procedure to solve, to compute this pattern using Rabin Karp string matching algorithm. So here you can see the step number one, what we have to do, we just compute the size of text array in n variable, size of pattern in m variable. Then we compute the value of hash value using Heron's formula d raised to the power m minus 1 mod q. Here d represent radix. Why use radix here? Because the most important thing in Rabin-Karp algorithm always apply in a integer array, or we can say a radix number. So we cannot apply Rabin-Karp in an alphabetical string like A, B, C, D, A to Z alphabet. So if our data value is in alphabetical form, in character form, so we replace the character into a given ASCII value, right? So after that, we initialize the value of pattern is to 0 and T0 is 0. And then we apply step number 6, 7, 8. In these three steps, we use a loop to compute. First, we compute the hash value. And after computing this hash value, one by one, we compare this hash value into our given text array to find a match. If our hash value is matched, then what we have to do, then we apply shift operations up to n minus m time, just like a naive string matching algorithm, and one by one we analyze the pattern, right? If we found pattern, then we print the valid shift value. If the value of shift is less than n minus m, then again we compute the value of t of s plus 1. So the total time complexity, again in the case, this statement will compute in order of 1 time. This loop will repeat it into order of m time. And if I want to analyze this loop, so the time complexity in that case is order of n minus m plus 1, and the size of pattern is n. So here the total, and this will again take constant time order of 1. So the total time complexity of Rabin-Karp string matching algorithm is order of n minus m plus 1 into m. I hope you understand the analysis of Rabin-Karp string matching algorithm. These are the references used in our presentation. Thank you.